बाद I will try my best to start paper 5. ठीक है? But before that, I have to start definitely. I have to complete the oscillation. अच्छा, oscillation में this was the next phase what I was discussing with you. Acceleration versus position graph, or acceleration versus position. तो बेटा जी acceleration versus position or velocity versus position, these are two important points which are to be discussed. हुदा आवाज आ रही है? हुदा, do you hear me? हुदा? ओके ओके, सो एक्सेलरेशन वर्सेस पोजीशन में हम लोग क्या करेंगे बेटा, आपको सिंपल एक लॉजिक बता रहा हूं कि दिस एक्सेलरेशन वर्सेस पोजीशन मींस दैट योर ऑब्जेक्ट इज हैविंग एन एक्सेलरेशन विद रिस्पेक्ट टू पोजीशन. अभी तक जितना भी हम लोगों ने पढ़ा है एट दैट टाइम, आप लोगों को मैंने एक चीज बताई कि बेसिकली आपका जो ऑब्जेक्ट है, दैट ऑब्जेक्ट हैज अ वेरिएशन विद, इसका जो एक्सेलरेशन था, एक्सेलरेशन का वेरिएशन हमने किसके साथ देखा था, दैट एक्सेलरेशन वाज बेसिकली नेगेटिव x नॉट ओमेगा स्क्वायर sin omega t, isn't it? Was it the acceleration now? Now this is basically here acceleration is a function of time. Remember this thing. So if I follow this equation, I must tell you okay, here in this equation acceleration and time graph is consideration, or acceleration versus time is my discussion. But if I want to link it, link the acceleration with position, then what I have to do, I have to shift this sine omega t. Yani I have to shift that sine omega t. For that purpose, what can I do for you? Here is a simple technique. As I told you that you have studied x is equals to x naught sine omega t. Is it? Did you people study this thing? X is equals to x naught sine omega t. That is an equation of displacement. Now from here, what is this sine omega t? That is equals to x divided by x naught. Is this clear to also? Is it clear to you also? So if I replace this in the main equation, x naught omega square, instead of sine omega t, if I write x divided by x naught, then what do you think? What will be the situation now? X naught and x naught will be gone, and now your equation is actually a is equals to minus omega square x. Did you notice this equation or this relation? Yes, Hanzala, Huda, and Zoya. Is this clear to you? Yeah. Beta, is it clear? What we are going to discuss
Yes.
right now? Okay. So basically, in this equation, what did you notice? That acceleration is directly proportional to the displacement. Yani, acceleration and displacement are directly proportional to each other, but opposite in direction. Directly proportional to each other, proportional to each other, but opposite in direction. You got my point? This negative sign shows this thing. So this is basically the relation between acceleration and displacement. Now, if I go ahead with the next equation, what I asked you people, that velocity was given by this equation. Velocity is equals to x naught omega cos omega t. Is it? Do you people agree that this equation was the equation of velocity or not? Do you people remember this? Okay. Now this again, this equation is in this equation, velocity is the function of time. I want to change it. I want to change it. But before that, I will prefer to wait. I will prefer to wind up that variation of acceleration and displacement. Okay, did you see that here the acceleration is directly proportional to displacement but opposite in direction? What does this show? This show that acceleration will be zero when your displacement will be zero. I mean that is at equilibrium position. You people get that point? Equilibrium position or at mean position, acceleration is always zero because displacement is zero. And acceleration is maximum when x is maximum. What it? So it means that acceleration is maximum where? At extreme positions, right? Is it clear to everyone? Okay. So this is how we can consider that yes, acceleration and this acceleration and this displacement are related. So that is why this is the graph which represents all that relation. Did you notice that, for example, if a simple harmonic motion or sorry, if an object is executing this motion at that time at x is equals to x naught, its displacement sorry, its acceleration is maximum, isn't it? But there is one condition: when acceleration is negative, displacement is positive. But on the other side, this x is equals to x naught, that is negative maximum, but that time at that time acceleration is positive. So this happens. This is actually a graph which is asked to you for 3 marks. That this graph shows that the motion of an object is simple harmonic motion, right? This motion is simple harmonic motion. I will explain that simple harmonic motion in the next topic, but here that motion is basically referred to this graph. That with the help of graph, how this graph shows that the motion is simple harmonic, because that graph is passing through region, that is a straight line, right? This is passing through region, and for maximum displacement, acceleration is maximum. These are 3 points what you have to write. Is this clear to everyone? Is it clear to all? बेटा, is it clear? Clear है सबको या नहीं? Okay, now I will just take short time of yours, but I will explain you one more thing, that what is the relation between velocity and displacement. It includes a small derivation, although that derivation is not included in your syllabus. But just for understanding, as I told you, that v is equals to x naught omega cos omega t. This was the equation of velocity, general equation of velocity. But as in now, I will uh, go ahead with the equation x is equals to x naught sine omega t. This is one of the equation which I will need, and from here from here sine omega t is equals to x divided by x naught. You have to keep this point in your mind, then I will be back. Now if I say that from trigonometry, cos square theta plus sine square theta, that is equals to 1. Do you people believe this? Is it now? So what about cos square theta? Cos square theta will be equals to 1 minus sine square theta. And if I say that cos theta is equals to 1 minus sine square theta under root, so it is not bad. Are you people getting this point? So ये क्या हो जाएगा? If I write that cos omega t instead of cos theta, then this equation will be rearranged as 1 minus sine omega t whole square. Now you people got a point, that is 1 minus, what was the sine omega t I have just written? X divided by x naught, na? So just go ahead, write it in this way, x divided by x naught whole square. तो बेटा क्या होएगा इसके बाद? You will just take under root of that, यानी you will take LCM of this. This is x naught square under the root. Then this is x naught square minus x square. I have just solved it, right? And this is your cos omega t. So guys, cos omega t is now equal to what? X naught square minus x square square root divided by x naught. Why? Because the square root and x naught, they are cancelled out, yani the square root and x naught square, they are gone. So is till this point, do you people have any query? Okay, now in instead of this cos omega t, I will replace this all. So that is why my v is equals to x naught omega. Instead of cos omega t, what did I tell you? It is square root of x naught square minus x square whole divided by, sorry, this is basically short x short root whole divided by x naught. So this x naught is cut by this x naught. So that is why your velocity is now equal to what? Your velocity is equals to omega x naught square minus x square. So beta, this is that equation which is very, very important equation. I am saying that this is even the most important equation of your oscillation, because this equation helps you out to figure out all the areas, even kinetic energy, even uh, potential energy, even total energy of the oscillation. In all these, this equation is used. Okay, so this is basically given to you, given in the data booklet, but its understanding was required. That is why I have made it clear to you, and I hope that now it will be clear. If you have any query, you people can ask me. Yes, is it clear? Okay. Now, from this equation, actually, why do I derive this whole equation, or why do I use this equation? Basic purpose of this equation is to study the variation of v and x. Yani, with respect to position, how do your velocity vary, right? How the velocity of an object varies with when it is having a simple harmonic motion. Okay, when what will be the relation with the velocity? Okay, now I'm just plugging the equation back here. V equals to omega x naught square minus x square. Beta, at x is equals to x is equals to 0, yani at mean position, what is your observation at mean position? Yes, what do you think? What will happen? What will be v? Yeah, yeah.
Yes, sir.
What will be the v at mean position according to this equation or according to this discussion? It will be omega x naught. It is, yes. Any question from anyone? Okay. 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 So till this point, any confusion? Sorry, yeah. Sorry for this background music. X is equals to omega. So basically, this is your maximum velocity. What is this? This is your maximum velocity. So this maximum velocity is, let me check. I received a message from Huda. Yes, Huda, very good. Velocity. Oh, yes, you are answering this question. Velocity. Actually, velocity is maximum here, because Huda, when your displacement is zero, you have placed all these values here and you got that v is equals to omega x naught. So this is the maximum velocity of any oscillator. V is maximum at extreme position, sorry, at mean position. Is this clear to everyone? So I can simply say that v is maximum at mean position. So when an oscillator is moving back to the mean position from anywhere else, its velocity is maximum. So this is basically, here I have mentioned all these points. I have derived it, but because that was already derived, so that is why I was thinking that it would not be convenient for you. But here you people can see that here I have mentioned all those areas. V is maximum at x is equal to 0. So what is the maximum velocity of the velocity? Maximum velocity of the oscillation, V max is equal to x naught omega. And at extreme position, I'm coming back to this empty page. What will be the velocity v at extreme position? Yes, at extreme, where x is equals to x naught, your equation, this equation would be, here instead of x naught you will place x naught, so your v will be equals to omega x naught square minus x naught square. So beta ji, your equation will be 0. So that is why what happens, that your v goes to 0. So please remember these all points, that variation of the velocity, v is maximum at extreme mean position, and maximum value of the velocity is this. You have to keep this point with you, that what is the maximum velocity or maximum value of the velocity. Yes, this is the maximum velocity. Okay, beta? Everyone getting this point? Yes. Yes. Calculation means, because you people are not having MCQs, that is why you people will be given some sort of data, that yes, what will be the velocity at which position. Are you getting my point?
Yes,
For
sir.
example, not at mean and extreme. Suppose I'm going to give you one more additional page here. Oh my god, so many pages I have added for you. And now these notes are enhancing day by day, because with every new student, I mean in every new batch, there are some new things to discuss, which comes out from the questions, right? Let's say this is a graph for a motion of an object. Okay, this is a graph for the motion of an object. So in that case, if I just plug in the gradient behind it, yeah, this way. So what do you think? Can I calculate the velocity of this oscillator at any position? This is an oscillator's motion, na? Isn't it? Do you think that it is something graph? No, no, this is not graph. Basically, what? This is the motion of an oscillator, which is represented with respect to time and position. So, if I say that the amplitude of this oscillator is actually, let's say, 0, 10, 20, and let's say it is 22. Okay, let's say it is 22 meters. So what is this amplitude? X naught is equals to 22 meter or centimeter, what does not matter. But if I want to calculate the velocity of the object when its displacement is how much? 15 meters, right? Now I'm free of time. Right now, what I'm going to do, I'm just calculating the velocity with respect to your position. So, what equation will help me? and which equation will help me? That will be omega x naught square minus x square square root. This is the equation that is going to help me out. So for this purpose, I need the time period. Definitely. So let's say the time period is 8 milliseconds, right? Let's say the time period is how much? 8 milliseconds. So can I calculate omega from this? Omega is equals to 2 pi upon t. So beta ji, just help me out please to calculate omega. 8 into 10 power minus 3. Yes. Yes, come on, come on. Hurry up. Do you people have calculator or should I open up mine? Hmm? क्या आंसर है बेटा?
So just a second, I just got it. I just got the gap.
Okay.
Approximately 790 or 800. Yes.
800 almost, right?
Yeah.
800 radians per second. Okay?
Yeah.
13,000. Okay. Yes. Hanzala, now it's your turn. And Huda, both of you, please. Okay, let's make it simple. It's not a big deal. Just I'm interested to calculate this number. Let's say 800 radians per second. What was the maximum displacement? Yes, my main concern is how to apply this. What is the maximum displacement beta? Our amplitude? Amplitude was 22 centimeters. Yeah, 22 meters is a square minus I am interested to find the speed at 15. So I can calculate that. You got my point? Oh, okay, okay. Oh, well. So it is 1300 meters per second. You got my point? 13,000. Oh my God, what a huge speed do I have? So this is how you people can calculate the speed. But the major issue is not this one. The major issue is beta ji graph. Okay, the graph of velocity versus position is very intellectual graph and very tricky graph. Why? Because as I told you that this graph is actually the graph of, I think so, axis to axis. Yeah. For this graph, this will be something like very interesting point, right? X-axis is what? X-axis is your displacement and y-axis is your velocity. Okay. So I'm just going to make it clear to you. Your x-axis is your displacement. That can be in centimeter or meter, whatever, right? And velocity v is your meter per second. That is your velocity. Now, as I told you, that the velocity is maximum at mean position. So let's say this is the maximum velocity of any object. You got my point? As the displacement increases, what about the velocity? You can calculate the velocity of this object, maximum velocity of this object. Yes. Can I have it from you? Can I have these calculations from you? What can be the maximum velocity? That will be equals to 800 into 22. That's it. Yes. Yes. Very good. Huda, well done. 17,600 and it's almost 18,000. So this value is your 18,000. And did you notice that as the displacement was increasing, the velocity decreases? That is why you people will get a decreasing gradient graph till this point. This is very important to now. Now the object comes back to the origin. This is the displacement. Yani the object is moving away from the main position. Now the object is coming back to the main position. So what will happen? The velocity will again increase and it will reach to the maximum value. Are you getting it? This way. Now the object will move in the opposite direction. Yani opposite direction. So if the object is moving away from the main position now, away from the main position, right, again velocity will increase or decrease and reach to zero at the main position. Yani main position nahi, it will reach to the zero at extreme position. For example, this is the extreme position. 1 2 3 4 5 units, displacement is 5 units, and here 1 2 3 4 5 units, so displacement is -5 units, right? Now again when the object is coming back to the main position, displacement decreases, the velocity of the object increases back, and how it moves back to zero in this way. So overall, you people are supposed to draw this type of graph for you, and that graph is basically very a unique graph this way. Okay, is it clear to everyone? This way. So these type of questions are asked to you, that what type of velocity time graph you will have. So here, for example, as here I'm saying that first half, this is first half. X increases, V decreases, isn't it? Because that is direct. If you relate that, when X will increase, if this number will increase, what about the overall number? Overall number will decrease, isn't it? And going back to this point, when X is decreasing back, then your velocity is increasing back but opposite direction, because that is a vector quantity. So that is why both are moving in opposite direction. Yani both are increasing, both are changing again but opposite direction. Now for third stage, what is happening? Your X is again increasing but negatively. Now square of negative does not make it different. So square of negative is actually positive. So again the velocity will decrease to zero. So you can say velocity decreases. For fourth stage, what is happening? X is decreasing back, whereas your velocity will increase back but opposite in direction. So this is how your velocity and position graph works. Is this clear to everyone? Okay, so here I have shown these graphs. There are, different questions which are asked to you, but here in these two graphs, what is the difference? Yeah, can anybody tell me? I have mentioned that difference here. The maximum displacement or the amplitude of A, this purple color is for A, the maximum amplitude of A is less than the amplitude of B. You got my point? That is why the purple color graph will be inside the blue color one. Okay, but the condition is if they have the same velocity, then. But if the velocity is also less, so it purple color graph will be entirely inside this blue color graph. Is this clear? And in the same way, if I want to draw another one, that velocity of X is less than velocity of A is less than velocity of B, but displacement of A is equals to displacement of B. So beta, what type of equation will you make? Or sorry, what type of graph will you draw? The velocity will be decreased, displacement will be Same. So actually your graph would be something like this. Something like this. Okay, for the students, I'm just drawing with the help of a software. For the students, there is a choice, there is an option that roughly that must be an oval or that must be a circle. Roughly, it is not mandatory, it is a perfect circle. So for this green graph, the displacement is same, but velocity is different. So is this all clear to everyone? Okay. So that's all. That's it. We will discuss, inshallah, the energies of oscillation in the next chapter, next class. Okay. Yeah. Okay. See, is that the class time is up now? Because we have to start the next class at 7:15, 7:25, 7:15. Okay. Yes. Okay. See you then. Just have a 10 minutes break. Then we will be back for AS class. Okay. Allah Hafiz Uda. Allah Hafiz Yahya. Allah Hafiz everyone.
Allah Hafiz, sir.
Allah Hafiz. And Yahya, problem is settled down.
Yeah, it is.
Okay, good. Thank you. Thank you for your cooperation.
Thank you, sir. Allah Hafiz.
Allah Hafiz.